Since we know already the four quadrants as A, S, E, C, where it is positive in the first quadrant, sine is positive in the second quadrant, tangent is positive in the third quadrant, and cos is positive in the fourth quadrant. Now, with respect to this part, we draw the graph of y is equal to sine of theta. It is written, this is y, this one is x-axis. The graph will be started from this zero value and it will go up till 1, and here it is -1. This is 90 degree, this is 180 degree, this is 270 degrees, and this one is 360 degrees. Since it is positive in the first two quadrants and negative in the third and the fourth quadrant, so sine graph is like this, and the range of this graph is -1 till 1. This is the range of the graph of sine of x there. And the period of this graph is 360 degrees or 25 degrees. With the same method, now we are going to draw the graph of y is equal to cos of theta. This is question. And this is the graph of this. This 90 degree, this one, this one is -1. This is 180. This is 270. And this one is 360. And the range of this graph is cos theta multiplied by -1, okay, 1. And the period of this graph is 360 degrees or 2 pi. And it lies between forward 1 and -1. Then the third type of the graph is y is equal to tangent theta. We know that at 90 degree it is infinity. So it will be an imaginary line which is known as we called asymptote. At this point with the dotted lines. Then it is positive in the first, it is positive, negative, negative, and positive in the fourth quadrants. And then it is negative in the third. Then it is again at 270. It is becoming infinity. So again, an imaginary line is drawn for this portion. And then up till 360, it is like this. So the range of this tangent function is -infinity to +infinity. And the period of this tangent graph is 180 on pi. Because after 180, it is going to repeat the same shape there. So these are the graphs for the individual function of sine, cos, and the tangents for this. Now we are going to use the topic of transformation for this graph. That let's say y is equal to f of theta there. Then, if this first property that if y is equal to a f of theta, then this a value is going to give decrease or increase in the values of the main function of f of theta with this amplitude. Now, if A has three categories for this part. First, if A is more than 1, then the amplitude is increased. And if A is lying between 0 and 1, then it is decreased. And if A is negative, then it is reflection out x-axis there. For example, y equal to 2 sin theta. This is the graph of sin theta from 1 till minus 1 up till 360 degrees. So this will be the graph of sin 2 sin theta there. That is, this value will become minus 1 and 1 will become minus 2 and 2 for the 2 sine of theta there. If we have to draw the graph of half sin theta, then this graph will be on the same shape, but its amplitude will become half and minus half till 360 degrees. If it is case of minus 2 sin theta, then we know the graph of this, which is the graph of 2 sin theta. And now there is negative sign outside of this. So it is deflection about x-axis. So same graph will become like this. That it will be minus 2 to this value of 2. Where it is positive first, now it is negative. Where it is negative, now it is positive. So these are the graphs of y equal to a sine of theta there. Similarly, we can draw the graph of cos of theta, tangent of theta with this property of a there, where a is going to increase or decrease the amplitude of this graph there. Then, y equal to f of a theta. Now, a is going to be multiplied with the theta angle there. So, period for sin theta and cos theta is 360 over a. And for period for the tangent theta will be equal to 180 over a. And a is in this figure is going to indicate the period of the function here. And after how many times it is going to repeat the shape for the original graph there. For example, y is equal to sine of 2 theta. Now, for the sine function, we know that it is 360 over 2 because a value is 2 there. So that thing is equal to 1. So it means it will complete one cycle up till 180 degree. So the graph of this will be like this 180, and again the shape of this, that is up till 360 from this 1 and minus 1. The range is still 1 and minus 1, but the graph is 2 times will be drawn with respect to the x-axis for this part there. If y equal to sine of 3 theta, then the period will be equal to 360 over 3, and that is equal to 120. So this means the graph will be like this will be one cycle, this will be the second cycle, and this will be the third cycle. So up till 360, it is going to make shape of the graph like this. But 3 times it is going to repeat there. If it is equal to sine of half theta, then the period is equal to 360 divided by half, so that is equal to 730. So same graph will be there. So 0 till 360, and this portion is the next from 0 till 720, and the range of this graph is 1 and minus 1. So this is the role of this a when it is multiplied inside the function there. It is basically, in other words, we can write this thing as when y is equal to f of a theta, then it is the stretching along x-axis. If y equal to a f of theta, then it is stretching along y-axis. So f of a theta means the stretching along y-axis, and f of theta, that means the stretching along y-axis there. Now, for the third part, if y is equal to f of theta plus a, that means what? It will be translation upward on y-axis there. For example, y is equal to sine of theta plus 2. This is the graph of sine theta from 0 till minus 1. So now we draw the graph of sine theta plus 2. That means every value will be 2 units translated upward there. So for this 0 value, it will become 2. and this is 2 units, it is going to go upward for that portion there. So this will become sine of theta plus 2. 2 units is moved upward there. And when y is equal to f of theta minus a, then it is downward translation on y-axis here. So, for example, y is equal to sine of theta minus 2, then the graph will be like this. So, this is the graph till 360, and 2 units has moved downward from the original graph there. So basically, it is the translation on the y-axis upward or downward, depending upon A. If A is positive, it will be moved upward, and if A is negative, it will be moved downward. Now, the last part of this graph is y is equal to f of theta plus A. Then it will be left translation on x-axis. For example, y is equal to sine of theta minus plus 30. Since the original graph of this sine function is this from 1 till -1, and now we want to draw the of y is equal to theta plus 30. So the whole graph will be leftward from this. So it is basically the leftward translation on the x-axis for this graph there. And if y is equal to sine of theta minus 30 degree, then this graph will move towards the right, and it will be like this part. It will become 30, and this will become 390. Again, it is the same amplitude there. So that means it is moved towards the right side for this minus 30 there. So if A is positive, it will move towards the left, and if A is negative, then it will move towards the right of this translation here. Now, we are going to draw the graph of this portion with all these properties together. Y equal to 3 sine of 2 theta minus 30 degrees plus 1. For this graph, we know that sine of theta graph is this. This is the graph of sine of theta. Then sine of 2 theta. That means is stretching on x-axis, and up till here it is 180, and this will become 360. So this is the graph of sine of 2 theta h. Then sine of 2 theta minus 30 degrees. So for this, you put 2 theta minus 30 degrees equal to 0, or theta is equal to 15. So this means the whole graph will be shifted 15 units towards the right side on x-axis there. So this is the graph of sine of 2 theta minus 30 degrees. Then there is 3 sine of 2 theta minus 30 degrees will be the graph like this. So it is 50 degrees. This is 75. This will become 195, and amplitude will become 3 to minus, and then plus 1. So this will upward there. So finally 3 sine of 2 theta minus 30 degrees plus 1. So the whole graph will be shifted 1 unit upward there. So instead of 15, it is at 0. Now it will become at 1. This 1, this will become 4, and this value will become minus 2. So this is the way that we are going to draw the sketch of this function with a transformation with properties of y equal to a f of x plus theta base. This is the final graph of y is equal to a f of b theta plus minus c plus minus b. So this is going to show as the amplitude. This is going to show the period. This is going to show left or right translation, and this d shows plus minus upward or downward translation for the graphs of this whole function, which is the combination of all properties of this function of the trigonometry there.